you in your life. we'll start, sir.
Okay, sir. Yes, sir.
All the best, sir.
Thank you, sir. Thank you.
A very good morning to one and all. This is day 2 of the webinar series, The Space Scientists. Yesterday, we saw an interesting presentation about the mission Aditya, and we were enlightened with the knowledge about the Sun and the mission Aditya, L1. And in today's session, we are going to see a webinar on satellite for public health. This is actually the need of the hour seminar because we are moving towards a new normal. If we want to see a doctor today, it has become almost tedious work to meet a doctor in person. So, what is the new normal? How to meet a doctor in this pandemic situation? There comes the solution called the telemedicine. And the government has already rolled out 2 schemes to support the public. Schemes like e-Sanjeevani, where the doctor will be available on call, but still the health system needs proper diagnosis. So that comes the solution from the satellite communication. So today's topic is actually the need of our topic for most of us. And I'm indeed very glad to welcome the chief guest of the day, Shri B.A. SUBRAMANI sir, Secretary and Station Director of Upagrah Amateur Radio Club, ISRO, Bangalore. Let us see a short intro video about our guest. Thank you. On behalf of the management and principal of Jansen's Institute of Technology, I would like to welcome Shri B.A. SUBRAMANI, Secretary and Station Director of ISRO's Upagrah Amateur Radio Club. He joined ISRO in the year 1984 and working as a space simulation engineer in the area of space environmental simulation test facilities. Since then, he is involved in conducting space environmental simulation tests on all spacecrafts, including Chandrayaan-1, Mars Orbiter mission, and the latest Chandrayaan-2, from various stages of their constructions at different levels like subsystem, system, and spacecraft level. He is a radio ham since 1986, holding an advanced grade amateur radio license with the radio call sign VU2WMY. He is active on all the amateur frequency bands and modes, including the latest narrow band software based digital modes. He has established more than 10,000 radio contacts with more than 150 countries across all the continents, including Antarctica. He is also active through various amateur satellites, besides being a vivid high frequency contester. He has bagged many appreciations and awards, the notable one being the Trans India contest, winning the first place consecutively for 5 years. He has contributed to great extents in the upkeep of ISRO's ham radio club station and successfully conducted several activities. He is one of the founder members of AMSAT India, an organization for design, development, and launching of amateur satellites in India. Currently, he is holding the post of Director, Educational Outreach Program of AMSAT India. Apart from enjoying the hobby from his home, he has often rendered his voluntary service and support in establishing and operating on-site ham radio emergency communication station for relief and rescue operations during several natural calamities and disasters. Notable ones are during the devastating floods and cyclones at Rajahmundry and Kadapa districts of Andhra Pradesh. He has also provided radio relay services during Latur earthquake and during cyclones at Odisha and southern districts of Tamil Nadu. His money contribution and supports also includes establishing and operating on-site uninterrupted emergency ham radio communication services for 16 days to the district administrations at Cuddalore during the 2004 tsunami. Currently, he is actively engaged in promoting the fascinating hobby of ham radio, shortwave radio listening, satellite tracking, and visual spotting of satellites and space objects, particularly among school children across the country. We welcome Shri B. S. Subramani sir and we hand over the session to him. Sir, unmute பண்ணிக்கங்க sir, Subramani sir.
Okay. Is it okay, sir? Okay, Vanakkam and Namaste and good morning, everyone. So thank you very much, sir. Thank you very much for the kind introduction. And indeed, I'm very, very happy to give my first webinar. And really, thanks for that. So firstly, I would like to place on record my sincere thanks to Janssen Institute of Technology, the management principal, and of course to Dr. Suresh, and also to the Galileo Science Club TN0014 Udumalpet and its coordinator and the main person, G. Kannabaran. So thank you very much, sir, for the invite and for giving an opportunity to meet your students and the space enthusiasts across the country. So thank you very much. So today my topic is, again, this is the first time I'm making a presentation on satellites for public health. So today, really, I would like to just give us a conceptual description about the satellite. So what kind of a satellite is required and what is the real public health based on the SATCOM. So I'd like to take you across my slides. Okay, so today my aim is just to acquaint and let know a common person about satellites and orbits and also the application with regard to the public health. So this particular satellite, it's not different from what the existing kind of or a type of a satellite. It's a special, but I would like to tell what kind of a satellite we choose to have this kind of a application. So in first place, why is satellite for public health? So when we have so many other means in the present day, so why is satellite is required? So this is what we are going to look into this. See now, so what is required is a technology that would allow doctors and patients to be almost anywhere, as Dr. Suresh mentioned. So at this point in time, where the situation due to COVID-19 is so severe that it is very, very difficult or maybe not advisable to go and meet doctors in person. And in this situation, a certain technology is required where doctors and patients has to be separated and still the diagnosis and the health management has to be done. So, as Dr. Suresh said, the need of the hour is telemedicine. So definitely this is very, very important. And though we had this kind of application for quite some time, almost since 2001 in India, but now it is very much required. So, so let us see what is actually the telemedicine is all about. So telemedicine is a system of remote diagnosis. That means without even physically seeing a doctor or the doctor being touching the patient or doing any of the treatments, without physically being in contact. So where a treatment can be given to the patient and a healthcare delivery and a management by means of telecommunication technology. So when we say telecommunication technology, so we have so many the present day applications like we have internet and we can do it with even the wired system and the wireless system. So today we are going to emphasize more on the wireless system. So without being a wired system, so how this kind of a telemedicine can be achieved. And what is the main purpose is? The main purpose of the telemedicine is to connect the far-flung areas like remote and inaccessible regions like hilly terrains and islands and of course economically weaker settlements across the country. So this way a telemedicine would certainly play a very, very important role. And also, the telemedicine can provide a local or a family physician an easy access and connectivity to specialist doctors, to and also to the specialty hospitals across the country, like the medically advanced cities where you have specialty doctors and specialty hospitals, thus bringing the service to the doorsteps and to the remote villages. And of course, the telemedicine is also very, very useful during religious congregations. So when people gather for a particular time or occasionally for the any for religious festivals or sometime, so such occasions, telemedicine is very, very important. So where the doctors on the site can get in touch with the specialists across the country and take their advice and diagnose for the betterment. So this is a one area where telemedicine is also very, very useful. Now, so having said about the telemedicine system, how it works, now the technical requirement. So what exactly we need to achieve this or accomplish this task or the application. So we need some certain technical requirements. And what I'm emphasizing here is it is based on the satellite. So now this is a SATCOM based telemedicine system. So for which essentially we need to have a satellite and that too in the geostationary orbit. And of course, this constitutes the space segment. So all that we need is a satellite in the geostationary orbit, and like any other satellite. And so what the ground segment consists of a video camera, a reasonably good resolution camera, a simple dish antenna, receiver, a modem, monitor, and a transmitter. So these are all this constitutes a ground segment. So now we need to have a simple ground segment as well as the space segment. So this is how the system can work. Now, having said about the telemedicine system and about the satellite, I just want to take you, since the topic is the satellite for the health, public health, I would like to just take you few slides, tell you about something about the basics of the satellites. What kind of a satellite we need and what are the different types of orbit. So I would like to take you to the few slides telling what is a satellite now. So let us know. I just want to tell you. So in first place, what is a satellite? So we all know that a satellite is a heavenly body which revolves around a planet in a particular orbit or a path. So we all know that very much, and we have two types of satellites. One is a natural satellite, another one is the artificial satellite. So natural satellites, we are all very aware that the moons in our solar system, for example, the moon in our around the Earth is a satellite, natural satellite for Earth, and likewise we have so many other planets having many moons. And the artificial satellites are those one built and launched into space by humans. So this is the difference and two types of satellites. And So why that satellites are so important? Every country, every nations, whether it's a huge or a tiny nations, every nation wants to have their own satellites and their own satellite systems. So let us see why the satellites are so important. So we all know that the today's satellite-based applications, for example, the first and foremost is the communication, because we need to have a very good communication system. So we use the satellites for this communication purposes. Apart from that, satellites are used for planetary explorations, TV broadcasting, weather broadcasts, of course, weather forecasts, remote sensing, cartography, fisheries, banking, and of course we have teleeducation. And besides, for military applications, relief and rescue, forestry, groundwater, of course, telemedicine, and numerous other applications. And it is almost, I know we have come to a stage that it is almost impossible to have our daily routine life without the existence of the satellites. Every time we swipe our credit card or a debit card, see all the transaction at one point in time goes through the satellite. So just imagine if there is a no satellite, or maybe if they break in the service for a few minutes, I think it's just going to be a very big catastrophe. So it is so much the daily life, the common man's daily life, the routines have been so much dependent on the existence of the satellites. Now, so this is what the satellites play such an important role in our life. Now, based on the applications, the satellites are classified. So all the satellites used for the different types of communication come under a group called communication, and we have remote sensing satellites, weather monitoring, or we call that also Earth observation, planetary exploration, and then reconnaissance for military purposes, and scientific, educational, experimental. And of course, we have another group of satellites called amateur. And this particular amateur radio satellites, it's meant for the amateur radio services used by radio amateurs across the globe. So, in what way the satellites is special? Why a satellite communication, or why a satellite is required? When so there was no satellite communication before 1957, unless until we launched the world's first satellite called Sputnik on October 4th, 1957. So before that, even the radio and the communication, telecommunication was there. So in what way this is special? Let us see the advantages of a satellite communication over the terrestrial communication. So the main difference is in the terrestrial communication, the coverage is very small. In means that the smaller the coverage area. So, for example, if you take a FM broadcast station or a TV television coverage, so the coverage area is very small. So hardly even FM station, a broadcast station can cover for about a distance of about 50 kilometers or 60 or 70 kilometers. So not more than that. And even if you go for HF communication, so the coverage is very small and it is not reliable. And because mostly these low frequency applications relies with solar activity like ionosphere condition, and of course the main difference is the bandwidth. So when the frequencies are lower and on the terrestrial communication, the bandwidth available is very small. So when you go to satellite communication, the coverage is very large. So literally or theoretically, we can cover half of the globe with one satellite. So the coverage area is very large. So that is the greatest advantage of going for the satellite communication over terrestrial communication. And also the satellite communication, it's very reliable and it's very predictable, consistent, and we have a quality radio communication system. And of course, you get a very higher bandwidths. So this is the main advantage why the satellites are preferred over the terrestrial communication. And of course, same time, we have disadvantage of a satellite communication also. So we all know that launching satellites into orbit is very costly, very expensive activity. And of course, we'll have a small propagation delay than the terrestrial communication. So when we talk about satellites, we often come across certain jargon, slangs, and words and definitions, something like an orbit. So now we know in a simple means a satellite is the one which goes around a planet. So when we say it goes around a planet, it can go in any direction, but definitely there is a certain path we follow. So we know how the satellite has to go over the globe around the Earth. So we call this path as an orbit. So if you put it in a right form, an orbit is a closed repetitive path along which a secondary body goes around the primary body. So now we can make the satellite to go around the Earth in any direction. So here we know that, so there is another orbit which is going over the poles. So we have made the satellite to go around the or poles. You can see another satellite which is going over the equator at a certain altitude. So we can make the satellites to go around in any direction. Okay, but we choose the orbit depending upon the application. So here in this bottom image, you can see the satellites, so one particular orbit is inclined, and you can see there is another orbit which is over the equator, and there is another orbit also over the equator, but at a much higher altitude. And so here we have an incline, there is another one highly elliptical and inclined. So we have different types of orbits, but we will concentrate on one particular orbit which is very suitable for the satellites for public. So here actually there is here file, but you are not able to see the motions here. So we have different types of orbits. Though there are different types, but these orbits are classified into three major types. And one is called the low Earth orbit, and so it can vary from the altitude can vary from 290 to 1,600 kilometers. And generally, these satellites are placed over the to go around the poles. So the satellites will just go over the poles, and we all know that the Earth is rotating on its axis. Earth rotates on its axis, and it takes about 24 hours to make one rotation. So you just imagine now, if these satellites keep going and taking a certain orbital period, and the Earth beneath the orbit will be rotating. So these kind of orbits are mostly used for the global application. And if you assume if the satellite takes, for example, 1 hour to go around its orbit, so the Earth beneath the orbit would have shifted by 15 degrees in 1 hour, because we all know that the Earth takes about 24 hours to make one rotation. That means that relates to about 15 degrees per hour. So if the satellite takes about 60 minutes, Earth would have shifted by 15 degrees. And the satellite will not be coming on the same plane again, on the same location on the ground. So it will be going over the other place, because the Earth would have shifted by 15 degrees towards west, sorry, towards east. So, and the typical time for orbit on during this low Earth orbit is range of about 100 minutes approximately. The typical orbital period is about 100 minutes. So this kind of orbits are used for global application. So, but here we cannot use this kind of orbit definitely for this public health when we concentrate on one particular geographical location. For example, if the telemedicine system, if we want to have it for India, so certainly we have to have a satellite which is really not going over the other places of the globe. So now we will come to the another orbit. This is called the medium Earth orbit. So it can be elliptical, and so there are again different types of orbits, highly elliptical and inclined and all that. And so we will concentrate on this geosynchronous orbit. So we have another orbit called geosynchronous or geostationary. In general, we say it is a geostationary. So though the satellites doesn't remain stationary in the orbit, it keeps moving because we inject the satellite with a certain terminal velocity, and these satellites, as per the Newton's law, has to just go around. We all know that it is not going to be stationary. So the satellite is going to go with the terminal velocity, and we call it as the injection velocity, and it keeps moving around in the same without changing its direction or its velocity. So this is how the satellite remains in the space without coming back to the Earth, at least immediately. So now, what we do, the launcher, the rockets will take the satellite and it will go over the equator and place the satellite over the altitude of approximately 36,000 kilometers. And so what we do, I'll just go to the next slide. This is a comparison, just a comparison for the polar orbit. So for a polar orbit, again, another disadvantage is the area of coverage is small. It is very, very small, hardly about 5 to 6% of the globe. But the geostationary satellites can cover almost about theoretically 50% of the globe. So now in this slide, you can clearly see a satellite placed at about 36,000 kilometers from the surface of the Earth can cover almost half of the globe. So theoretically, it's about 50%. Practically, it comes to about 42%. So almost 42% of the globe can be covered with one single satellite. So this is the greatest advantage. And the reason why we choose a geostationary satellite is so what we do, we make the satellite to synchronize with the rotational velocity or the orbital period of the Earth, the rotational period and the orbital period of the satellite. So we all know that the Earth takes 24 hours to make one rotation, and the satellite also will go around the Earth, and this will also take about 24 hours. Thereby, the rotational velocity of the satellite, see, this is the orbit. So the satellite keeps moving like this, and the Earth also keeps rotating as if the satellite is tied to a point on the ground. So the rotational velocity of the Earth and the rotational velocity of the satellite are synchronized. So we see that the satellite also takes about 24 hours to make one orbit. So at a distance of about 36,000 kilometers, and again, the satellite cannot remain stationary, though it appears to be stationary because of the synchronization. So this is what we call as a geostationary orbit. So,
Sir, Subramani sir, sorry to interrupt.
Sir?
You can stop sharing the camera, sir, so that there is a distortion in audio. You can stop sharing your video.
You mean video, sir?
Yes, sir. Yes, sir. Yes, sir.
Is it okay, sir, now?
Yes, sir. Perfect.
Okay.
Okay, sir.
So otherwise, was it okay, sir? Until then, until now?
Yes, sir. Yes, everything is going good, sir.
Okay, sir. So, now, this is called the geostationary orbit. So this is another projection called map projection. So now you can see this is a world a map. So the satellite is placed here. For example, I've taken inside 2E as a reference. So just to tell you the coverage area, this is the green area. So a satellite placed over this point in the space can cover this much of area. So that means any station within this area, the stations or the persons or ground stations can interact with each other. So this is the coverage area, and it will remain constant. The coverage area will remain constant. To give you an example, the DTH. See, now we have a DTH system. See, we all the satellite signals, all the TV channel signals, they all come from a particular satellite. And a DTH antenna on the terrace looks at one particular position or a point in the space. It actually pointing at a satellite. The signals from the satellite is coming through this dish antenna. So the antenna doesn't move. So it is stationary. The antenna is also stationary. The satellite is also stationary, though both keeps rotating. The Earth is also rotating on its axis, and the satellite is also rotating. This kind of a satellites typically move at a velocity of about 3.2 kilometers per second. So you can just imagine the satellite is moving in the space around the orbit around the Earth over the equator at about 3.2 kilometers per second. So this is the rate at which it travels. and still it appears to be stationary. So this is the one concept. And with just three satellites, we can have a global communication, a complete global coverage. So three satellites is 120 degrees apart. So this was first devised by Sir Arthur Clarke. And so he has devised this system, and this orbit is also called as Clarke's orbit. So three satellites can literally cover the entire globe, and so we can have a global coverage. So this kind of a satellite services system can be used for the global coverage. So when coming to again geostationary, so this orbit is circular. It is placed over equator height of about 35,863 kilometers very precisely, and it revolves around the Earth at the same velocity as Earth rotates. Hence, this satellite appears to be stationary over a given point on the Earth. So this is what about the geostationary. So we need this kind of a orbit and a satellite placed in this orbit. So it is like any other communication satellite. So let us see what are the advantages of the geostationary satellite over the other orbits. So advantages are it is a large geographical area coverage, almost 48% of the Earth surface. Yeah, I told 42. Yeah, it's about 48%. It is about 48% of the Earth's surface can be covered with one single satellite. And this satellite will be available for 24 hours continuously for a single fixed location. And generally, this satellite life is for about 15 years. The satellites are designed to stay in the orbit for about 15 years. So that is the greatest advantage. Another advantage, because most of the polar orbits, the life will be about for 3 to 5 years, or worst case for about 7 years. But in this case, this one single satellite can stay in the orbit for about 15 years. And it is very ideal for radio or for satellite and radio broadcasting and for other multi-point applications. Just three satellites to cover the entire Earth, and it is ideal for broadcasting and multi-point distribution applications. And of course, there is no Doppler shift. Technically speaking, the frequency won't keep changing with this kind of, because there is no relative motion between the observer or the ground station and the satellite, and hence there won't be any Doppler shift. And the design of the receivers and transmitter becomes very, very simple. So that is another technical point. And of course, we have disadvantages. So the disadvantage of the geostationary satellite is a small delay in the time. So about 120 milliseconds delay, time delay in one direction, and because of the distance, and so we have this time delay, and we have to live with this. But this is not going to be that critical for other applications, except for very, very critical applications like uh, warfare, and for the tactical weapon deployments, and other for missile deployments, and for those applications. But otherwise this is not going to cause much difficulty. And the other disadvantage is this satellite being put over the equator, it cannot really cover the polar regions. So the coverage will be very poor over the 77-degree latitudes, whether it is in the south or the north. So above 77-degree latitudes, the coverage will be very, very poor. So that is the reason the polar caps, particularly the northern polar cap, the countries over that place cannot use these geostationary satellites for the communication purposes. So now, so we will come back to the again the type of telemedicine services. Now, I hope you would have gotten a little idea, maybe a technical idea, how a satellite is chosen, selected to provide this kind of services. So we have to go for a geostationary satellite as a type of orbit to have this kind of services provided. So now coming back to the telemedicine services. So let us see. Is it only the satellite can provide this kind of services? No, it is not only satellites. Of course, we can have, as I said, wired and wireless system. So here, using a wired system, so we can have this kind of a telemedicine services. Earlier days, people were using even the telephone landline systems to for the telemedicine services. And later on, So when we got the internet services, broadband, so using a high-speed terrestrial broadband services, this kind of telemedicine services can be really done. So for example, as Dr. Suresh told, so we have so many other apps now for this present situation, pandemic. So where we can use our internet, email, and so many other, in the sense, all kind of the what do you call this? Like using cell phones and the internet, we can use the high speed broadband services. So by using this, by using a simple computing devices by used by the patients or the physician, and second thing is a very inexpensive cell phone equipment like smartphone. So we all use the smartphone cameras, and of course we use the wearable biosensors to have this kind of a telemedicine services. So, but what is the problem with the terrestrial broadband services? The penetration, because the broadband services are not available at all the places. If you take what you call the remote villages, the availability of the internet or the broadband services are not very poor. So we need to have connect the, if we want to connect the entire country. So certainly we have to go for the space-based telemedicine services or maybe a SATCOM system. And so we have two types in this. One is the store and forward. It's called also called as a asynchronous, where we can send some of the information to the databases, and the receiver can take it at their convenience. So just mean it's a one way. At any point in time, it could be one way. I can just send some information to a doctor telling about my condition, and doctor will take his own time and he can get back to me. So this is called the store and forward. But whereas we have a real-time systems wherein the sender and receiver both are online at the same point in time, and a live transfer of voice and video information can occur. So both these kind of telemedicine services like a store and forward and real time can be used can by using high-speed terrestrial broadband services, which most of us we are using for all the apps, the web-based apps now, cell phone-based apps. So we are all using now, like so many other apps now. What we are using it. So now the other system is it's a SATCOM, satellite-based telemedicine services. The advantage is it's a satellite-based communication service. It's a very unique, and it can reach almost half of the globe. So whether it is an island or an ocean, maybe a ship bound, so anywhere to any terrain like a hilly terrain or valleys, anywhere the SATCOM services can be provided. It can be accessed in the sense that any remote village can also can have access to the telemedicine services once if you have a satellite in this particular orbit. So now, so let us see what was the scenario in India. So that was basically ISRO's initiative, and India was the first country to launch a dedicated satellite for telemedicine applications. So way back in 2001, we had a pilot project and linking Chennai's Apollo Hospital with Apollo Rural in Chittoor district. So India had a dedicated satellite for the service, and it was very popular. So and Department of Information Technology, Ministry of External Affairs, and Health and Family Welfare departments. So they all played a very vital and important role in the development of telemedicine services in the primitive days. And we have set up a task force. So Government of India has set up a telemedicine task force by Minister of Communication, Ministry, Health Ministry. And a good amount of work has been already done in this area in India. And so of course, not only for the India, but India has taken up even projects like Pan African E Network project and SARC country telemedicine, SARC telemedicine network projects. So we have done a good amount of work in this area of telemedicine by ISRO, but as a nation we have done it so much. And of course, as I said, so Indian contribution, we are the pioneers in the telemedicine services. And as I told, ISRO's telemedicine network has come a long way since 2001. Now it is expanded so much, and almost all the rural hospitals and the super specialty hospitals in the country are connected through this telemedicine network. And so for the remote nodes include the islands of Andaman and Nicobar and Lakshadweep, hilly regions of Jammu Kashmir, and all these have been connected using the telemedicine services. Now, as ISRO's societal SATCOM services, ISRO has introduced a new scheme as a service called Village Resource Center. It is nothing but the a modern version of the telemedicine. So we have an integrated service called VRCs, wherein it's not only telemedicine but teleeducation, online decision support, interactive farmers advisory, telefishery, e-governance services, weather services, water management. Everything has been provided using this village resource centers. So now more than 500 such VCRs has been functioning in this country. So catering to different societies, sections of the society with the various services. So this is one of the greatest societal services by ISRO. So this is as per the Vikram Sarabhai's vision, like to take the fruits of the space to the common man. So this service has been doing wonders since it was launched. So the future trends. Now, see, recently the government of Tamil Nadu also made an initiative that they want to reach to the student fraternity through the television classes, like because the online classes through the internet is because it cannot reach all the students, because most of the villages, many villages doesn't have a proper internet network. The reach of the internet is not there. So now they are making, that is what we heard through the news, that Tamil Nadu government has come out with an idea to make a video classes and then to broadcast it through a satellite, using a satellite in the geostation orbit, and then it will be received by all the districts, and then it will be distributed to the cable network, wherein all the households, even in the remotest village, can get these programs and the online classes can go on. So it is exactly, but it's going to be a one way for the time being, but maybe in the future it can become interactive, a two-way. So that is how this can be done. So the future trend is that we are going to have a satellite-based, very high-speed global broadband services. So that is internet directly from space, like how we have direct-to-home television. So now we are going to have direct-to-home internet service from space. So some international companies are already working on launching, planned and already launched a couple of satellites, and soon so we'll be having a internet, so where it could be more easily accessible and maybe very inexpensive once if the system is in place. So this is what the future trend is going to be like. So to have, so we can have not only telemedicine, or we can have tele-education also using this, and of course we can use it for social media also once if this kind of services are available. So at the moment in India we have this village resource centers, and wherein so we can have a lot of facilities. And so, what I would like to say is that so all this, even a small clinics, nursing homes, and the hospitals, again, they can all come together. They can have a consortium. They can have their own satellites with the multiple transponders to cater to the needs. And so the entire country can be connected probably with a single satellite. And so we are going to have a very good healthcare system in the world. So this is possible by using the technology available, and especially by using the space technology and satellite for that particular purposes. So as a bottom line, I would to like to conclude by telling that the technology involved in telemedicine allows doctors and patients to be almost anywhere. That means they need not meet each other. So which is very, very need of the hour for this particular time. And even though the telemedicine cannot be a solution to all the problems, but it can surely help decrease the burden of the healthcare system to a larger extent. So, with this, I would like to conclude my presentation. And I really thank everyone because this was my first webinar. I don't know how the technically it went on, but I would like to thank everyone, all the listeners for their patience. And I hope I just made a little point about the satellites and the different orbits and the kind of the telemedicine services already we have and how we can have and how the future is going to be like. So thank you very much. Once again, I thank the Janssen Institute of Technology, Coimbatore, and Galileo Science Club, Udmalpetai, for giving me an opportunity to meet you all through this webinar. And thank you, Dr. Suresh and Kanabiran and all the listeners around the country. And of course, I heard a few from other countries also. So thank you very much. All have a wonderful time. Take care of yourself and your family members. Stay safe and bye for now. So the namaste once again from Subramani here. Sir, is it okay?
Yes, sir.
Yes, sir.
Thank you very much, sir. Sir, any questions or anything I need to answer, sir?
Sir, Kanabaran sir will take over, sir, the question answer session.
Yeah, please, Kanabiran, please go ahead.
Yes, sir. Good morning, sir. Once again, very nice presentation. So, some of the questions the students are asking. The first question is, sir, Abdul from Shalem. He is asking, what about the reliability of telemedicine as it can be hacked?
Okay, good morning, Abdul. Good question. See, we have to live with the situations. Hacking is there everywhere. Okay, and certainly I feel that no one would like to hack a system which is meant for a certain, very good purpose. So, but hacking, satellite hacking and all, it's not that easy. It is not like that, but still, technically that is possible. That is possible, but of course, any network for that uh, system can be hacked. So, but I don't think anybody will do for this kind of when a telemedicine system is going on. So that's about the hacking, Abdul. Go ahead, sir. Tanabran?
Sir, the second question,
Go ahead.
how can a ham radio be useful in disaster management? A student named Prajan from Kobe Public School has asked this question.
Okay, regarding ham radio, that itself is a different topic. Certainly, we can meet them during other sessions. But ham radio has got a greater advantage over other systems. See, why a ham radio or see maybe a wireless system is preferred during disasters is because it is a very much an independent system. Ham radio doesn't have a middleman like a service provider. See, for example, now this particular session is being conducted by using a service provider called a broadband service provider. So, if there is a break in the system, certainly I am not going to be hurt because it is a dependent service. This is a service dependent service like in a service provider, whereas a ham radio is not dependent on anything. So that is the main reason why a ham radio can be put into use during natural calamities and disasters. I hope you got it. Go ahead, Kanadaran.
Uh, Thank you, sir. The third question is from Madesh Bharatwaj. So, what is Doppler shift?
Roger, hi Madesh. Nice to hear you, Madesh. A question from you. And Madesh, a Doppler shift is see, whenever there is a relative motion between a transmitter and a receiver, so there will be shift in the frequency, though actually there is no a shift, but certainly at the receive end, there will be a feel of a shift in the frequency. For example, see, when you stand near a railway gate, And when a fast moving train is honking and passing you, so we hear and notice a change in the pitch or the frequency of the horn of the train or a fast moving vehicle or a motorcycle. And this is called the Doppler shift. So actually the frequency, the received frequency shifts because it is due to the relative motion between the two, the transmitter and the receiver. So that is the effect, and this can occur with any fast moving vehicle, and it can also happen with the transmission made by a satellite, because the satellites are moving at a very very fast rate, and whereas the ground station is fixed, but there will be is going to be a relative motion between these two things, the transmitter and the receiver, and there is going to be a shift in the frequency. And so this is called the Doppler shift. I hope you got it, Madesh. Over.
Ah, thank you, sir. The fourth question from Bhairav Shankar. The question is, what is the main purpose of the geostationary satellites?
Okay, I already mentioned that the greatest advantage of the geostationary satellite is the service will be available 24/7. The satellite will be available all the time, though it is moving over its orbit around the Earth at about 3.2 kilometers, but this will appear to be stationary. Like when we are traveling in a scooter or a car at certain velocity, and maybe another vehicle traveling at the same velocity. So then, when there is no relative motion between these two bodies or two persons, they both appear to be stationary to each other. So this is the real concept that is happening the geostationary satellite with reference to a point on the ground. So these satellites will be available all the 24/7. Like the classic example is DTH. All the TV channels, the programs, what we get from the satellites are from the geostationary satellite. So this is the greatest advantage of using a geostationary satellite. Is it okay, Kanapura?
Okay, sir. Okay. Thank you very much, sir. Sir, Suresh, sir,
One more
any more
question, sir.
questions?
One more question from Sahana. She
Yes.
wants to know whether launching of a satellite affects the ozone layer.
Okay. Yeah, certainly, because we emit a lot of the rockets emit a lot of the smoke, and at in one point certainly that is going to have a, net effect on the depletion of the ozone layer. So, like any other emissions, rocket also emits, but the care has been taken out to keep the emission to the lowest level. But there is going to be a small effect on the ozone layer. That is for sure. Correct?
Thank you, sir. It was really a wonderful session, sir. We still keep getting questions. Maybe I'll collect all the questions and I'll email it to you, sir. We can answer them offline.
Okay, sir. Sure, sir. Thank you very much, sir.
Yes, sir. It was really exciting to hear about the telemedicine and the direct-to-home satellites to bring about the internet facilities. Those are all very exciting factors, and we are also moving towards new normal in our life. So ISRO is playing a very big role in safeguarding and for the comfort of the humanity. And being associated with ISRO and Ham Radio Club, you are also doing a wonderful job, sir.
Yeah, thank you, sir. The main purpose, what I feel is the conduct of this webinar series by Janssen Institute of Technology and Galileo Science Club is to mainly motivate and inspire the younger generation to take up science, the pure science. Because yesterday we had a great session by Dr. Arvind Ranade, and also tomorrow we are going to have one more great session by Dr. Venkateshwaran. So the main idea, what I feel, is to just inspire and motivate the younger generation to take up the pure science in the career. So hopefully, I think they'll get motivated and inspired by this kind of a series of talks. So that is what I feel, sir. So thank you very much once again, sir. Anything will stand by. Otherwise, I'll say once again my sincere thanks to you and Kanapiran and to the management and to the principal for giving me a wonderful opportunity. So certainly, I'm very very happy to make my first webinar. Thank you, sir. Thank you, Suresh sir, and thank you, Kanabiran.
Thank you, sir. Thank you for sparing your time in spite of your very busy schedule. I know how busy you were and you are. Uh, and now I request Mr. Kanadaran sir to propose the vote of thanks.
Thank you, Suresh Kumar sir. Johnson Institute of Technology, Coimbatore, and Galileo Science Club, Udmalpet jointly organized so many programs in person last 3 years. So these webinar series has started the second day today with the topic of satellite for public health. Our chief guest and my dear sir friend as a friend of ham radio, ISRO Satellite Center Upagrah Radio Club Station, Shri SUBRAMANI sir. He has given nice presentations. Already, Suresh sir mentioned some of the things like telemedicine, satellites. So these information help us to develop our knowledge regarding about the satellites and how to know about the
Hello, I think we lost connectivity. But anyway, he wants to convey his thanks to the guest, the management, and to the all the organizers of this webinar series. Uh, this is not the end of the series, it's just day two, and hope to see you all in tomorrow's session. And thank you very much for the guest and the co-host and all the organizers, and have a good day.
Sir, thank you, sir. Sir, Suresh sir, thank you.
Thank you, sir. Thank you very much, sir Subramaniam, sir.
So, okay, sir. Thank you, Kanabiran. Sir, can I just close down, sir?
Yes, sir. Yes, sir. Yes, sir. We can.
Oh, thank you, sir. Thank you. Bye. Have a nice day, sir.
Yes, sir.